Today we are going to be writing our exponential equations based off of a table or a graph. So we just want to remind ourselves a few important things about our exponential equations. And the form is going to be y equals ab exponent of x. And sometimes you'll see us write that as parentheses b and then the exponent of x, especially if we have a value of a that is not 1. So a is going to represent our initial value, and b is going to be the rate of decay or growth. The rate of decay or growth, that's what those represent. So when we're looking at a table, that's where we're going to start, is looking at a table. The value of a is the value of y when x is equal to 0. So this would be the y-intercept. So we're going to look for the y-intercept for a. If we look at the table to the right of us, we can see that here where x is equal to 0. So our y-intercept is 20,000, and that is the value of a. And then for b is the rate of decay or growth, which is the common factor for the y values, which means what number is multiplied to each y value. In order to calculate that, I'm going to look at the y values on my table, and I'm going to try to determine what number they are all getting multiplied by to get the next number. To do that, I'm going to take my y value, and I'm going to take the number immediately after the 1700 and divide it by the y value. And as you notice, our numbers are getting smaller. So this is a decay, so our number should be between 0 and 1. So it's going to be a fraction or a decimal. Between 0 and 1, it should not be greater than 1. And when we divide that in our calculator, we get 0.85. So b is 0.85. So our rate of decay is 0.85. So to write our equation, we have y equals a, which is 20,000, parentheses, 0.85, close parentheses, x, and that is our equation. So find your y-intercept, find what number is multiplied to each y value, and plug them into y equals a parentheses b, close parentheses, exponent of x. So we'll look at another example here. Again, I need to find my y-intercept. It's happening when x is equal to 0. That is going to be the value of a, so a is going to be 10. And then I'm going to look at what each number is multiplied by. So to go from 10 to 30, that's multiplied by 3. From 30 to 90, that's multiplied by 3. And again, to go from 90 to 270, it's multiplied by 3. We can find that if we aren't sure. Take a value for y and take the previous number and divide. So 30 divided by 10 is 3, or you could do 90 divided by 30 is 3. It's all going to come out with the same number. So b is 3. And so our equation will say y equals 10, parentheses 3, close parentheses, exponent of x. Looking at our last table example, we have no visible y-intercept. I don't have when x is equal to 0. So instead, first I'm going to start by finding the b value. So we have to look at what each number is multiplied by to get the previous one. So 16 times what is 8? 8 times what is 4? We can take 8 divided by 16, And we find that that is 1/2, or you can say 0.5. This is going to be a decay since it's between 0 and 1. I'm going to use 1/2, but again, you can use 0.5 if you want. So to work backwards, I need to figure out what number multiplied by 1/2 equals 16. To get our y-intercept, because our previous x value is 0, because we're going 1, 2, 3, 4, so the previous number would have been 0, which would be our y-intercept. And so I'm going to take the reciprocal, the flipped version of b, and multiply it to 16. So 16 times 2 over 1 will give us 32, which is going to be our y-intercept. So a is going to be 32. So our equation is going to be 32 parentheses 1/2 close parentheses exponent of x.